So welcome everyone to today's IVI Coffee and Talk. We're delighted to have Christian Muck from the University of Vienna presenting for us today. So Christian is going to talk about digital design science. So if you can keep your questions to the end and we can have a Q&A and discussion after that. I'll hand over to you, Christian.
Thank you very much for this nice introduction and for introducing my talk. I think you should be now able to see my screen, hopefully.
Yeah.
And what I want to talk to you about today in this 10-20 minutes is the presentation with the title From Abstract Concepts to Digital Models, with digital design thinking with Scene to Model. So what I want to do is give first an introduction of what we're doing, where we see the problem, what we want to address, and then I want to introduce our proof of concept tool, which is called Scene to Model. But before this, I want to give you a short background to myself, as I'm not from IVI. As it was introduced, I'm from the University of Vienna. To be more precise, from the research group Knowledge Engineering, which belongs to the Faculty of Computer Science. And we are one of the few research groups with a focus on business informatics. So business informatics is also my background in the bachelor and the master. And our focus is based on conceptual modeling and creating modeling methods and tools for modeling methods using meta modeling. So just short background from where I'm coming. And now I want to start kind of with the problem that we see and how we solved it, and then I will go to the proof of concept tool that I want to show live. So I don't think in this environment I have to motivate and discuss how complex it can be to find good solutions or innovative solutions in this age of digitalization, digital transformation. If discuss this in the Q&A, of course. But what is here important for me or for the research group where I'm coming from is that this is usually a very complex problem with multiple stakeholders, different interests, and different parts that makes it complex. For example, the environment where this innovative ideas must be applied, getting more complex and complex, different services, interacting with humans, and also now with Internet of Things and services systems, the hardware and the environment gets more intelligent and more complex to handle. On the other hand, we need sophisticated domain knowledge. So what is exactly the goal? What should be achieved? What are the parameters in which we can work, for example, from the regularity prospect, from the law, from what do the people want, the users, or other stakeholders involved. But we see in this intersection of complex environments and this domain knowledge, there is a possibility for innovative solution which can take from both sides and then make something new and really useful for people if we can bridge this gap. And how we want to address this is we identified some ingredients which we think is useful and helpful. And of the one side, we need some exploration of ideas. So we have to find new ideas in a creative way. And of course, if we want to implement them, we need them to describe them in a comprehensible way so that people can understand it. Therefore, we took existing approaches like design thinking for this creative exploration and conceptual modeling for this comprehensive way of describing. And of course, we just don't want to do this in parallel, but we want an integrated way of doing this. So we need some technologies on board so that we ease the user in doing so. These are kind of the three ingredients which I want to talk about and how we combine them with our proof of concept tool. But before I come to this, I want to shortly introduce the design thinking aspect. Don't worry, I don't give an introduction to design thinking, but what technique we used for our proof of concept, which is the scene to model, which I will introduce later, so that hopefully I can better explain what we're doing and why we're doing this. So for creating this proof of concept, we took one existing design thinking method, which is SAP Scenes in our case. SAP Scenes is created from SAP, that's the software enterprise from Germany. They also started to doing design thinking approaches and creating them. And we took this one because it's very easy to understand for us. So it's easy to understand what you should do. This is on a high abstraction level, so it can facilitate communication between different stakeholders. And of course, it's free to use for non-commercial usage, which is why we take them. And what is SAP Scenes? This is a storyboarding approach where you visualize the user story with a storyboard, but not like drawing the different key scenes, but they provide you with paper figures, which you can then use in the workshop. So come together with people, put the paper figures on the table, and explain the story. And then you can interact with the story in this tangible way, which should foster the creativity and the co-creation in the workshop. So just to have an example, this is, for example, one paper figure, which you can print out and cut it out and then use to put it on the table. There is, if someone is interested, there's a nice video on their webpage, but which I do not want to show today because of the time limitation. But what we with this design thinking approach and others is that then the people in the workshop who created the story have a found idea of what is going on, what should be done, and what are the framework which they can operate, but how to get this knowledge out of this workshop and share it with other stakeholders. But this could be done, of course, with just taking a picture or writing a long document, but we want to go another way to more capture the essence of it. And what we did was we created a conceptual modeling method representing the SAP scenes. So that we have a more sophisticated way of describing what is in the scene and creating these figures. And of course, according to the framework that we use in our research group to describe and create modeling methods, it's not only sufficient that you have here a modeling language, which guides the concepts that you can use, how they look like and what they mean, but you also should guide the user to create useful models so that they get the most out of the created models, which includes a modeling procedure, so a way to create these models, and of course, and also a way of processing the information within the models or help an automated way to create this model. And for us, this is that we do not want to just replace the design thinking approach, in our case, the paper figures, with a digital model, with a user interface where you can drag and drop the elements, but we want to combine these two so that you can use both in the workshop. You can use the paper figures and have all the benefits from it, and afterwards you can use the model to describe it in more detail. So that is not just a picture, but you have the different objects which are adaptable. You can add additional information to them. You can later on also add and remove concepts within the scene. Of course, we don't want to do this again by hand because nobody does this and it's cumbersome, and it kind of interrupts the flow within the workshop if you have a stop and create it and create the scene so they can use it in the workshop. And therefore, we want to get from the paper figures on the left-hand side to the model on the right-hand side, and this in an automated way. Therefore, we identify two steps that must be taken. One is recognition, and the other one is the mapping approach. So first of all, we have to identify the paper figures or the objects that were used in the scene and the position. This can be done, of course, in different ways. For example, putting a tag on it or something more conventional, like adding to the paper figure something that is easily recognizable, or you can also have more sophisticated approaches like convolutional neural networks to really train them to identify the objects itself. And then how, depending on how you recognize, you have to map this information that you get to a way that it can be interpreted by the modeling tool, and hopefully also enrich it with additional information needed in the domain where the workshop is applied. So, for example, we use ontologies to get information and provide it. And if we have this, we can enable this automated transformation. And this means then that we have a model which we can then use directly in the workshop again, or afterwards share it, adapt it, save it, and whatever you want to do, or also make some automatic processes of the information. And how did we do this in the scene to model? So we choose an approach with text. So we search for easy recognizable in a picture. We take a live stream of it, we identify the text, we calculate the position, give it to the mapping. The mapping enriches this with information. Then we can now have the right-hand side here our digital model with some also characteristics to the individual concepts used. So it's not just the picture that we humans can interpret, but there's also some information which can be shared and also used by the machine. And so how do we do this is here we have a camera which is directed at the paper figures, and we then transform this, and this is what I want to show live now. So I will just remove my background, and I have here added this to on the table. So here we have our camera, which is taking the pictures of the scene, and down there we have our paper figures positioned on the table. And as you can see here, we have this enhanced with the text. And so this is what is done in the workshop. People come together, they position the paper figures on there, talk about it, rearrange them, and get to know this important part of the story. And after they are finished, I now change to the modeling tool, which you should be now able to see. And after finished, you can create here a scene model, which are already prepared. So this is an empty model with nothing in there. And then they can click here and get this information from the table. So that nobody thinks that I lied. I now took the watch here and do it again, and the watch. So this really really live. And as I said, you can then use this to rearrange it, to make it more appealing. You can add information to the objects. Each object has what we call a notebook where the information can be entered. Of course, you can also enter and add additional information, for example, a textual note. Or you can even implement other conceptual modeling approaches which you can use. For example, we added here processes so that you can then afterwards you finish the story, you can rework the created story in the workshop itself and adapt the models, and then you can also add processes where it's needed. I also provided a short example how can then the result look like. So we have here added the text to the different concepts. We have added text and notes. We have added the different processes which can be used. And this is this combination we talked about. And of course, we can process it because we want to create storyboards, not different scenes. So this is one scene, one key moment of the story. And if we have multiple of those, like here, we can create here a storyboard automatically, which just takes a picture and put it one after another, and then we have a nice overview. And of course, this is linked to the different scenes. So if you want to go in there, you can do this easily. And we also, for the business processes, we can get all this information of the needed processes. and get an overview of the, sorry, the name was already taken, of all the processes that we defined in this tool. And I think I should to the end. So I just want to end with some reflection what we have done in a SWOT analysis way. So the strengths that that I see here is that we integrate existing approaches, so they are well known, they are already used, and we combine them. And of course, we combine this tangible and this digital representation. So we have the best of both ways. And of course, if we have this in a modeling environment, we can then enhance it and adapt it with additional information, like for example, the processes. Some weaknesses that we have at the proof of concept is that we cannot recognize text, and many design thinking approaches are based on post-its with text. Yeah, the available paper figures influence what you can express within the story. So it should be fitting to the domain that you apply it, and of course you have to adapt it beforehand at the moment. And some threats is that, of course, these models, then people do not recognize the value of the models. They just say, okay, I take a picture and this is sufficient. Or maybe some days this mixed reality, virtual reality environment gets so good that you don't need this tangible parts anymore. So that is exactly, but what we think is huge opportunities is that all this technology that you can use to identify and map this information becomes better and better every year. So you can, with convolutional networks, you can very quick identify the different objects, for example. Then you have open link data where you can extract information from the World Wide Web to fill automatically in there. So I think with advancing this technology, we can also improve the overall process of the Sinto model. So, and then thank you for your attention. If you have any questions, feedback, I'm glad to hear. Further questions, of course, you can reach me under my email address, which is shown here. So, thank you. Are there any questions, any feedback, comments?
Hi, Christian. I have a question. That seems really interesting, and I know about your research because of the meeting that we had before. And just I was wondering if you have any plan to run similar workshop here in IVI.
I have not a concrete plan, but I have prepared a workshop. So a testing workshop, and we can adapt it. So if you want, we can. I would be glad to do this to let people experience it more. But there's no concrete plan.
Yeah, that would be great. Thanks very much. Yes.
Thank you.
Hi, Christian. Thanks for the talk. And I have two questions. One is you already said that the software is not able to recognize text. But assuming that you have a scenario, a use case that described just in text, so how can you translate that in a model? So you have to first build a paper model, then give this to the software that translates in the conceptual model, or can you do something else if you don't have the model in a visual form?
So I don't know if I understood the question correctly, but you asked me if you can also do something else with post-its, for example, or with
no. If you don't have, assuming that you don't have a visual model, so that you just have a text describing a use case or whatever, a reality, and so you don't have something visual. You have just a text describing it. What can you do in that case?
No, I understand. This is a very interesting question and approach, and we now have a master student back at our university who looks into this in the first way. So I at the moment have have nothing in this direction, but we have an approach which natural language processing and mapping this to the meta model of modeling language to create these models. So we think this is usable and useful in the future, but it's nothing that I'm looking into.
Okay, thanks. Okay.
Yeah.
And second question was is so, and this of course applies to models that are just limited representation of reality. So do you have a way of measuring how close is the model that you build to the real thing? So is a way is a measure or not? Or do you have an evaluation somehow that you can some way to understand how close is the model to reality?
No, I don't have this way. There exists there exists approaches, for example, with process mining, where they try to evaluate how the processes are modeled and should run, and how they are really run in the company using log files of applications and something like this. So there exists approaches, but there's nothing that I looked into for the scene to model tool. So this is more on this ideation and creating ideas side of the spectrum, not then something you can evaluate against what you have done or what is done in the company so far.
Okay, thanks. If nobody else has a question, okay, yeah. I still have another question.
And thank you very much for a wonderful presentation. Okay. It's really a nice work. I was just wondering, you mentioned that you are mapping the ontologies as well. So I was just curious if you were doing it semi-automatic means or a manual mapping of the ontologies.
In this proof of concept, which is available, we have a predefined ontology which we map, which you have to adapt manually. But we are working at the moment also on something to map it to existing open link data or portals so that you can generate it out of it. But there's nothing that I can show now. But this is what we look into, because we think is very useful that you can reuse this open information, and you don't have to put anything by hand and predefine.
Definitely, because I was of the view that if you go for a semi-automatic means, then you can use the linked open data concept, and you can, keep on growing and enhance your model as well. So that would be interesting.
Yeah. So we have at the moment a prototype with DBpedia, where we try to extract class information from DBpedia. Yeah, but this is still some further work to do, but of course what we think also would be very helpful. So if you have any specific good endpoints for extracting information useful here, I would be very happy.
Yeah, definitely, I'll share it with you. And more of it, I was just looking at your this publication, Professor Amin Chua. He's one of the author. So he was my supervisor back in PhD. So I worked with him for 4 years. So definitely I'll share some of the information with you. I have your email address. I have noted it down. I'll share some information with you on this regard.
Okay. Very nice. Thank you.
Yeah, back to my third question is no, but actually is related to what Mansoor said, because and you already mentioned, it's very important to reach your model with open data, linked data, because the DBpedia you were mentioning is very useful and can have a very rich models. So my question is, okay, can you say very quickly? So for example, some practical use once you have your model, so with all, let's say the conceptual model with reached with all the information, for example, taking from DBpedia. Some practical uses of the model. That what can you list some some of the uses that one can do with your let's say the result, your artifact.
Yeah. So I just want to mention that my focus is on this transformation and how you can use this. But of course, what you can do is dependent on. I think it sounds a bit broad, but what you want to do. This modeling tool is implemented on a meta modeling platform, which is called 8xx, which is available, and you can of course adapt everything you want to do. But what we have already looked into in some student project was, for example, to share information in the kind of crowdsourcing environment where you post it on social media with some automatic generated questions out of the model, so that the information from the model is used to create some questions, and then you can post it, and then people can comment on the picture, and you can kind of analyze it. What is done, for example, sentiment analysis is what is shown in the scene, then positive or negatively reviewed. Or another thing was that if you, for example, do this in as design thinking workshop in different places. So for example, you're an international organization and you do this in Vienna, here in Maynooth, and maybe in America, then there's some way to compare the model, what the 3 different models, for example, you can compare them. What are the differences? What is the same in there? So something like this. And what we also do is we have in our research group, we have this OMLab environment where we do prototyping, where this is kind of we have a 3-layered approach. We have the business model, the conceptual models, and the proof of concept environment, which, for example, has some type of systems or information systems. And then we use these models up there from the business model, for example, this SAP scenes, and transform them in an experiment to make a prototype based on model execution that you can facilitate what you want to do or evaluate, so that you use then this, transform this in an executable model, then execute this model in an experimentation environment, so that you can get a feedback during this creation time. So this is something that we looked into. Hopefully this answers your questions.
Yeah, thanks.
So we're just at about 2 there. So if anyone has any more questions for Christian, as he said, you can contact him there at his email. Just to say thanks very much, Christian, for a really interesting presentation. And just to let everyone know that next week we'll be having our coffee and talk at the same time. We'll have Umair Ul Hassan from the School of Business presenting. And also a date for your diaries is March 3rd. We're going to have our first webinar of 2022, and this will be focusing on designing digital transformation with enterprise architecture. So thanks again to Christian, and thanks everyone for attending today, and we'll see you soon.